Today is day 2 of our review. So yesterday we started looking at complex numbers and at quadratics A. Today we will continue with a few more quadratics A problems and a few examples for quadratics B. There will also be about 15 minutes at the end of the period if you would like to continue test corrections from yesterday, and for you to have some time to look at your review worksheet. So the first thing that I would like to look at is I'm going to give you a general form, and I would like you to get it into factored form. So if this is the general form, how could you get this into factored form? I will give you a few moments to try and get this into factored form while I pause the recording. For the first step, what is one of Mr. Server's favorite sayings? Can't factor it, you should. Did we have a question before we started? You were going to say the first step? All right, would you like to guide us through the first step? So if we factor out a 2, because we should factor, what do we end up with inside the parentheses? 36. Okay, so we factored out a 2. And now we have these two terms here. And what do you notice about these two terms? They're both perfect squares indeed. And if it's a perfect square, then we can use our special rule called the difference of squares. And if we look at just this first term here, and we take the square root, what do we end up with? We end up with 6x if we take the square root. And then if we look at our second term here, square root of 25 is 5. So the difference of squares tells us that our two factors are both going to start with a 6x, and they're both going to end in a 5. And if we need to multiply to get a negative, what do our two signs need to be? One positive, one negative. Then we still have this 2 out front. And if this is what you write on your test, you will get a partial credit because you need a y equals. This is an equation. You must include y equals. Okay, show of thumbs. I got this. I would like another short example. I have no idea how to do this. Okay, let's do one more. I don't believe you guys. I think we should do one more. Let's do, I have, let's go with 9x squared minus, actually no, I changed my mind. I don't like that one. Let's go 16x squared minus 144. Y equals 16x squared minus 144. Put this into factored form. And I will pause while you do. If we look at this, and I call on row 6, person 6, that would be George. Could you tell us what you did to get your answer?
The square root of 16x squared to get 4x, and then the 144 to get 12.
So we took the square root of both of those terms, and we found our two factors. And what needs to be in the middle? So you get a plus and 1, a minus another, and what are we missing? Y equals. So this might be one answer you got. Other people might have done this a different way. They could have seen, I know that 16 goes into 144. So y equals 16 times x squared minus 9. And what you have remaining, isn't that still two perfect squares? So you would end up with 16 times x plus 3 times x minus 3. Those are both the same. If you ended up with either of those, they would be perfectly acceptable. Okay, let's do something that's not the difference of squares, but let's stick with factoring. I gave you, let's see, and I'm going to change this to a minus. Could you factor that? I will pause while you try and factor this one. We've taken some time, tried this one out. This one is slightly difficult because we have some value for our A coefficient. And it's not going to factor out nicely. So row 6, person 5 would be Aiden. Could you tell us what you did for your first step here? Or just what your factors were? Okay, so you put it over here? Okay, so 4 times negative 15, which is negative 60? Okay, so negative 60 to get to negative 4. Okay, when you did this, did you manage to find your 2 factors? Not at first? Okay, let's call in somebody else. Would you like to phone a friend? Okay, would you like to phone a friend? Would you like to tell us your 2 factors that you got?
Well, I didn't do this way.
That's okay. You still end up with 2 factors.
I got, like, for my answer,
Yes.
2x plus 3, and then 2x minus 5.
Okay. So the hardest part about these kinds of factors is that there's no real trick besides just having to try and guess and check. So for this, if we look right here at the 4, I'll use a different color. If we look at this 4 right here, we know that it's either going to have factors of 1 and 4, or 2 and 2. And if we look at our 15 here, we know it's either going to be 1 and 15, or 3 and 5. And from there, it's just a matter of matching and trying to find a combination that will get us to this negative 4. If we have these 2 factors now, and I wanted to ask you what the roots or the x-intercepts were, can you find those x-intercepts? Take a few moments. I'll pause while you do. So if I ask row 3, person 1, could you, Arzana, tell us what one of your x-intercepts were?
I got negative 3 over 2.
Negative 3 over 2. And if we wanted to put that into our coordinate point, what would the y value be? 0. Awesome. Would you like to call on somebody?
Sure. And then you take 2x minus 5.
All right. And so what would your other x-intercept be?
5 halves.
5 halves, comma 0. So remember when you're solving for the x-intercepts from factored form, what does y equal if you're looking for your x-intercepts? It equals 0. So you're not just looking at this term. You are looking at the whole thing, and you will set 2x plus 3 equal to 0. And you will solve for x. So you'll end up with negative 3 halves and 5 halves. Okay, we are going to step away from quadratics B and do a few, step away from quadratics A and do a few quadratics B problems. So, what? I am just doing select problems that I think will be important for the cumulative, but the cumulative will most likely have more than what I am reviewing. So I would invite you to use the review sheet. Let's see. I believe it is 10 or 12 problems, which is why we're doing it over the course of 2 days. No. Overall. Overall, 10 to 12.
The same difficulty as like when we took the test?
It will be a little bit different because for these problems, we're not going to separate them like we did with all of the individual tests. So stuff on quadratics A could be combined with stuff from complex numbers or from quadratics B. So it's But as long as you know all the concepts, I think it'll be okay. It is testing your knowledge over the past 3 units. So complex numbers, quadratics A, quadratics B. Yes, but it is also a way to help. So a cumulative is basically, you're going to have a final at the end of the semester, right? If you have a final, would you rather study off of the 3 cumulatives you've taken before the test, or would you want to study starting at the first test you took all the way back in September? So the cumulative kind of helps you review throughout the year, or throughout the semester for the final, which is why we like cumulatives. Okay, for quadratics B, I would like to do a complete the square problem, and I would like to do a projectile motion equation problem. Which one would you like to start with? Who says complete the square? Who says projectile motion? All right, most people just don't have an opinion, so we're going to start with complete the square. For completing the square, I would like you to complete the square for this problem, or rather for this quadratic equation. And please be careful with this problem, because this is the first time you've probably ever had to factor out a fraction. And if you factor out a fraction, for example, if I had, let's say I had 6x plus 4, and I had factored out a half. If I factored out a half and I distributed them back in, are these individual numbers going to get bigger or smaller? They're going to get smaller when I factor this back in. So this would end up being 3x plus 2 if I factor the 1/2 back in. Here, you are factoring a 1/2 out. If you are factoring a 1/2 out, will the remaining numbers get bigger or smaller? Bigger. All right, I will leave you to it. We would like to just complete the square and put this in vertex form. That's a good question. I will pause. We want to find the vertex form. To find the vertex form, as I had said before, we are going to pull out the 1/2 first. And once we pull out the 1/2, everything on the inside gets bigger because we're pulling out a fraction. So here, instead of -5, it will not be -5/2. Instead, it'll be 10 because everything gets bigger. And we have a plus blank, and we just leave that plus 11 on the outside. Interesting. Okay. So let's not go out there right now. If we were looking at this and I wanted to know what goes in the blank, row 5, person 5, that would be Lube. Could you tell us what you put in the blank here? We have a 25. And if we have 25, we added something to the front here. What do we have to subtract by? Minus 12.5, because this 25 is affected by the 1/2. So 25 times 1/2 is 12.5. So we have added 12.5 to this side, which means we need to subtract 25 from that side. So we will end up with 1/2 times, if we factor this out, it'll be x minus 5 squared. And then over here we have 11 minus 12.5. And that altogether gives us negative 1.5. So there's our vertex form. If we took this, and then I asked you to find the x-intercepts by solving this, try doing this without using the quadratic equation. We want to find the x-intercepts. And if we are finding the x-intercepts, as we said before, we want to set y equal to 0 and then solve. So please do so. I will pause while you work. If we are looking for our x-intercepts, we said we want to set our equation here equal to 0. And if we set it equal to 0, our next step would be to add 1.5 to both sides. So if we do that, we will end up with 1.5 is equal to 1/2 times x minus 5. 5 squared. From here, then, we want to get rid of the 1/2, so you can divide by 1/2. And dividing by 1/2 is the same thing as multiplying by 2. So I'm going to multiply both sides here by 2. And if I do that, I'll get 3 is equal to x minus 5 squared. If I do that, and then I take the square root of both sides, I will end up with the square root of 3 is equal to the absolute value of x minus 5. Here is a warning. This is what I saw a lot for the last test in terms of mistakes. Square root of 3 in this step, and then they just had 3 in this step. Square root of 3, the square root does not go away in the next step. Please remember to keep it. From here, we have our two cases of x minus 5 is equal to the square root of 3, and x minus 5 is equal to the negative square root of 3. And if we add 5 to both sides for both of these cases, we will end up with x is equal to 5 plus the square root of 3, and x is equal to 5 minus the square root of 3. You can write it as those two. Otherwise, you can combine them as 5 plus or minus the square root of 3, and they are equivalent. Okay, before we have a little bit of work time, I would like to do one more problem, and it is a projectile motion problem. Yes, gross, which is why we're going to practice it, so you know how to do it for tomorrow. So, show of hands, who here has watched Emperor's New Groove before?
Oh yeah.
No. If you haven't, you should. Emperor's New Groove is a pretty great animated cartoon.
Wait, is that
It's got Kronk with the llama. Yes, the llama and Kronk and Yzma. Okay, so who remembers the squirrel? The squirrel's name was Squeakers. Okay, well there was a squirrel. His name was Squeakers. And the squirrel is sitting on top of Kronk's restaurant. And Kronk's restaurant is 12.9 meters high. Okay. Also, true fact, squirrels can run at a speed of 5.4 meters per second. That's faster than me. Just saying. I can't run that fast. Okay, so our squirrel here is running at a speed of 5.4 meters per second. And since he's on top of the restaurant, he decides that he wants to jump down off the roof and onto Crocs Head. And Crocs Head is, let's see, Crocs Head is at a height of 3 meters, because this is a pretty tall guy. And he's got a huge hat. He's got a huge hat. Okay, what I want to know is how long would it take our squirrel Squeakers to land on Crocs Head? We know that we always start with our equation of height is equal to negative 4.9 t squared plus the initial velocity times t plus our initial height. So from here, figure out how long it would take the squirrel from when he jumped to land on Crocs Head. I will give you time to work on this problem. We haven't had quite a lot of time, but if we are looking at this right now, and we just want to put our equation together, row 1, person 5, Sam, could you tell us what you got just for the equation, the base equation?
Yeah, I got 0 equals negative 9
Okay, this equation right here, you might have some differences. One of the differences you might have is you might have started with just negative 4.9 t squared plus 5.4 t plus 12.9. And then you would have said, okay, this is equal to the height. And what is the height that we want to end at? 3 meters. So all Sam did was at this point, she subtracted 3 from both sides because our quadratic equation has to be equal to 0. Has to. So if you did this, you would have gotten that. And from here, if we are solving for t, what formula do we have to use? Our quadratic or our quadratic formula. So we'll have the opposite of b plus or minus the square root of b squared minus 4 times a times c. If you take this and you were to solve it out, one of your times would be negative, and we don't want the negative one. The other time would have been something like 2.08, or you could have gotten something that's like 2.2 or anything up to about 2.6, I believe, depending on how you rounded it. Okay, for the remainder of the class period, I will give you time to work. I will give you time to ask questions, especially if you were here or you're stuck on this problem. Okay? But I did want to pass out tests so people who wanted to look at test corrections would have time to work on that. So I'm going to end our recording here.